So here we're going to talk about testing. So the next step would be after you finish graphing your variables of interest, now the thing is that you want to be able to test them. Now, when it comes to testing, it's going to be a little tricky because some of them are easier than others. So the first two that I'm going to do, I'm not sure anyone's going to use them, but just in case, I'm not sure. So the first thing is we've already know the z-test for proportions. We've already been tested on this. Here is when you use it. You want to use a one sample z-test when you have a proportion and you are comparing it to a known value. So here are the assumptions. So some of the assumptions you do have to check. You need to make sure that you have normal data and that you have a large sample. Now, one way to kind of know if we have kind of like a large sample, just look at your observations. Okay, just go ahead and look at your data, see how many observations you have for that particular variable. Okay. So what you want to be able to do, the first step is basically have an alpha value. So usually alpha will be 0.05 if you really want to. Your other options are 0.01, which is 1%, or 0.10. Okay. Usually I think a lot of you are going to pick this one. I will actually explain in after I do these testing videos what alpha really means and what is the whole purpose of alpha. So remember that so once you have your significance level, what you want to have is your null hypothesis and your alternative hypothesis. And remember that with the null hypothesis is going to be P is equal to some number of interest. And then P is going to be greater than, less than, or not equal to. For this particular, I don't know, for this particular project, I think everyone should do a not equal to. Just because you're not sure if things have increased or decreased, I think. So I think it's safer to just put a not equal to in there. Okay. Now, usually what we would do, we would solve these using a test statistic and everything, but we're going to have Statcrunch do everything for us. Now, how do I know whether I should use a one sample z-test for proportions? Well, if you're comparing a categorical variable with a known number, then you might want to use this type of test. So if I go to my data, maybe I'm looking at the proportion of people who are full-time. So maybe I think that the proportion of full-time people is going to be 50%. I think that at Mesa College, there are about 50% of students that are full-time. Okay, so that's maybe my hypothesized value. So what I'm going to write in my null hypothesis would be that HO P is going to be equal to 0.5. Okay, so this means that the proportion of full-time is going to be equal to 50%. My alternative will be that no, it is not going to be equal to 0.5. It's something completely different. So either the proportion of full-time students have increased or they have decreased. Okay, so this will be my null and my alternative hypothesis. So now what we would do is we would conduct this test. So if you're using a z-test for proportions, this is what you're going to do. So you're going to click on stat, then you're going to go to proportion stats, and then you're going to click on one sample, and then you're going to do it. First, let's go ahead and click on with data. Okay, so with data, what you're going to do is you're looking at full-time and part-time, so that's just FT and PT. Okay, so I'm going to go all the way down to FT and PT. Then the success is going to be full-time. Now you have to be very careful because this is going to be case sensitive. So make sure that the way that it's written here is going to be here. So full-time, because we're going to look at full-time. Then you're going to see hypothesis test for P. P in this case is going to be equal to 0.5. So that was already there. Here you have a couple options to change it. Okay, you click on that, not equal to, leave it alone. So compute. And then what you're going to have is this cute little results thing. So you want to be able to copy all of this out and put it in your report. So here's your null and alternative. And then you have basically the variable, you have the test statistic, which is right here in the z-stats. You can see that it's a really high test statistic. You have the number of people that were full-time, and then out of 103, which is about, it's really, really high. And you can see a really low p-value. So then after that, you make your decision and you write your conclusion. So based on this, since the p-value is low, we're going to reject HO, and then we just say we have sufficient evidence to blah, 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 blah. So that's what you gotta say. So make sure that you write your decision, and then make sure that you also write your conclusion. Okay, so make sure that you write that in your report. Okay, and then the next one that I'm gonna do on the same video is gonna be the one sample t-test for means. Okay, so here the way that we did it with proportions was, well, we had a p. Well, imagine that with t-test is gonna be with mu. Okay, so we're gonna have our null, and we're also gonna have the alternative. And here what we're doing is that we're using this test when you have a mean and you're comparing it to a known value. Whereas before it was a proportion and you're comparing it to a known value. So let's say we were looking at a mean, okay, and the number. A mu, it can be greater than, less than, whatever you want, and not equal to a number. Let's just say not equal to, okay? So again, we have to have our alpha. Let's say alpha is going to be 0.05. And let's say in this case, we are comparing, I don't know, let's say we were comparing GPA. So let's look at the GPA variable. And what I think is that I think that the mean GPA is going to be 3.0, okay? And my alternative would say that, no, it might not be 3.0. It might be either greater than or less than or something, okay? So this is my HO and my HA. And now what we're going to do is test it. So we're going to go to here. Let's get rid of this. So what you're going to do if you have doing a t-test for a one sample mean, so it's just one sample, you're going to click on stat, then you're going to click on t-stats because it's a t-test. One sample with data. And now what you're going to do, you're going to click on GPA, okay, because that's what the GPA, that's what you want. You don't have to do anything over here. Then hypothesis, well, we think that it's going to be 3.0. And then this is going to be not equal to, so that's fine. So we're going to click on compute. And then here is what you have. Oops, I super maximized it. So here you have the mean of the variable. You have your HO and your HA. And then you have your sample mean. So basically, when I took the mean of all of this column, I ended up getting 2.9. My test statistic was negative 0.39. And my p-value was large, 0.69. Okay, so then at that point, you see that your p-value is much higher than your significance, so you're going to fail to reject, so you don't have enough evidence to say that your mean GPA is not equal to 3. It's probably around 3. It's still the same. Okay, so those are the two different types of tests. So you're going to do the same thing that you did with the proportions. You're going to write your decision and your conclusion. So I don't know if anyone is going to be doing any of these two tests. I'm not sure, but here they are. And in the next couple of videos, we're going to do more different types of tests.